Always had a fascination with building things, like the stuff that was not in sets, because I always found the sets constraining. But something that was more generic, you could let your imagination go free, right, and build whatever you want. I think that was sort of the genesis of it. And, mechanical engineering is really like the generic engineering, right? You touch everything. I went to Lawrence Livermore National Laboratory really to work on the U.S. national effort for developing a fusion power plant. We were mandated, you need to use today's materials when designing and building this fusion power plant, and that meant we had to be creative with geometry. I found that there was this one manufacturing technique called laser powder bed fusion that could get you the right metallurgy and also really any geometry you wanted that could meet all of our design requirements. The problem was it was so slow and expensive, it was going to take 200 years to build one of our fusion chambers. We need a faster way of doing things, and so we came up with one. And that evolved and grew into what later became Seurat.
When I'm working with customers, one of the first things I always ask them is, what do you wish you could do? Using area printing, we can finally unlock that. As opposed to subtractive manufacturing and additive manufacturing, we're creating objects with lasers to melt powder, and there's no waste in that process. We're able to use green energy to power the lasers, and all of the powder that isn't used in the process we can reuse for the next build. By printing large tiles, 10 millimeter today, roughly 10,000 times larger than a typical laser powder bed fusion system, we're able to print at unprecedented rates, which meets our customers' needs for producing parts at scale, measured in tons, not kilograms per year. We can produce their designs without requiring them to first go through a complete redesign for additive manufacturing. Because additive manufacturing doesn't rely on design-specific tooling, companies get really excited about applying additive manufacturing to their product lines. We're able to change how products are developed. Rather than going through a lengthy process, designing a tool, and then hoping for a great outcome, we can actually iteratively design parts. We can manufacture them and test them and receive that feedback in real time, and then create a better version of that product. This allows our customers to achieve any of their engineering objective. We can be extremely energy and material efficient in a way that no other manufacturing process can, and deliver a better product in the end. This shortens the product development cycle, it reduces your risk, it allows and accommodates change in the design process. It ultimately transforms production workflows.
The core was solve this problem in fusion, but very, very quickly we realized, wow, this is going to have huge implications for manufacturing, because if we can print these fusion chambers, which were going to take 200 years in under a week, that amount of speed up means huge productivity. So now you can talk about high volume part production for our customers near our customer sites, or production on demand, so you could reduce warehousing costs and warehousing space, right? No longer do you need to build all the spares you're going to need for an automobile right up front because you have the tooling. You can build them as needed and greatly reduce the amount of warehouse and storage and maintenance space that's required for those parts. The evolution that Seurat has taken from our technology perspective, it's a little like going from writing a letter with a pen to the printing press. Making metal parts takes a lot of energy. We see two main mechanisms for impacting green manufacturing. One is direct, one is indirect. So direct, is we're a fully electrically driven process. In fact, we are making the commitment to get all of our electricity from non-CO2 emitting sources. So if we're competing on a price point basis with processes that are historically emissions heavy with one that is emissions free, there's an opportunity there. Then there's the material wastage, right? We're an additive process. That means we only use the material that we need to create our part. Indirect is, okay, now we're making this turbine blade for a turbine, and with that turbine blade, that turbine can now be 5% more efficient at creating electricity. In the next few years, we're looking to deploy our production part manufacturing factory, where we can, at scale, manufacture high volumes of parts for our customers. But to outfit that factory, we also are going to need to deploy the next equipment manufacturing center. So we can produce not just, one machine a quarter, but, dozens to hundreds on a yearly basis. We're also going to want to be qualifying thousands of parts for customers to fill the factories, right? And enable us to go deploy more factories through project financing. It's going to be an exciting journey. It's going to be an exciting path, but the goal is we're going to be making a better world, and we're going to be making our customers happy in the process by allowing them to scale all the incredible possibilities that they can come up with and really bring them to life.